Today we are going to review solving one-step equations. While we are solving our one-step equations, we must remember our goal. This must stay in our mind the entire time. And our goal is to isolate the variable. We want to get the variable by itself. So to do that, we are going to go ahead and follow these steps to get that variable alone and get our solution. So the first thing that we'll do is box our variable, put a box around it so we know that's what we want to get by itself. We also are going to draw a line down from our equal sign. And the reason that we do that is to signify a balance beam or a scale of sorts. So that line right there reminds us that on both sides of our equation, we need to keep everything balanced. All right, we're going to ask ourselves, how can we isolate the variable? And we do that by using inverse operations. Now, our inverse operations include addition, the inverse subtraction. Subtraction, the inverse is addition. Multiplication, the inverse is division. And the inverse of division is multiplication. So when we have either one of these, we inverse it. So we try to get that variable alone by using the opposite, that inverse operation. We must remember that whatever we do to one side, we have to do to the other side. We must keep it balanced. And that's what that line down from the equal sign helps remind us, that whatever we do to one side, we must do to the other side. Lastly, we are going to check our answer by substituting our solution back in. So once we get our value, our solution, we check our work. We substitute that value in and make sure that this value we found makes our sentence true. So let's try a couple of practice problems here. Let's start up top. We've got x plus 4 equals 6. So to recall, our first step is to box the variable and draw our line from the equal sign. So I box my variable and draw my line. From there, I ask myself, okay, well, how do I isolate that variable? How do I get that x by itself? I need to use inverse operations. So here I see that we are adding 4. To inverse adding, we subtract 4. Because I subtracted 4 to get x alone, these two cancel out. Adding 4 and subtracting 4 gets me right back where I started. X is now alone, but because I subtracted 4 here, I must do that on the other side as well. I can bring down my x. The box can be removed. It's already by itself. And then I say, okay, 6 minus 4 equals 2. So this right here is my solution. Okay, I've got my solution, but I must make sure that it is in fact making my equation true. So I've got my equation, x plus 4 equals 6. I like to rewrite it exactly so I make sure that I'm filling it in correctly. I take that x equals 2, and I substitute it in. 2 goes in for that x, add 4 equals 6. Okay, so is that true? Does 2 plus 4 equal 6? Well, yep, 2 plus 4 does equal 6. So therefore, this solution will make my equation true. All right, let's try another one here. We've got x minus 2 equals negative 7. All right, so again, I can box my variable. That's what I want to get alone. I draw my line, my balance line. I look at what operation is occurring, and I see here that it's subtraction. So to inverse subtraction, I add. I add that 2 back so they can cancel each other out. Because I added 2 here, I add 2 here. I bring down my x. Now I have negative 7 plus positive 2. That will get me negative 5. Now I have my solution, but I must substitute to make sure that it's correct. x minus 2 equals negative 7. So I substitute in that negative 5. Negative 5 minus 2 equals negative 7. Because it's subtraction, I turn that subtraction sign into addition and use the opposite of that second number. Negative 5 plus negative 2 does equal negative 7. So I am good to go. All right, let's try a multiplication and a division problem. All right, so we've got negative 4 times x equals 20. Again, I can box that variable. I look here, there is no operation, which means, of course, that I multiply. To inverse multiplication, I divide. Now, something that I see very often is we forget to bring that negative with us. That negative is attached to the 4. It's a negative 4. That negative must come. Okay, so we divide by negative 4. Now those cancel out. I have to divide by negative 4 on this side as well. And I'm left with x equals 20 divided by negative 4 is negative 5. So again, here I have what my x value is, but I want to go ahead and double check that. I substitute in negative 5 for x, and then I check my work. Does negative 4 times negative 5 equal 20? Sure does. There we go. All right, one more example here. Here we've got division. So again, I can go ahead and box my variable, draw my line, keeping myself balanced. Here I've got division, x divided by negative 5. So to inverse that division, I'm going to multiply. Those cancel out, but I must also multiply here. Again, don't lose your negative. We've got to keep that attached to your 5. I am left with x only on this side. That was my goal. X is alone. Now 8 times negative 5. Well, 8 times negative 5 is negative 40. So again, I have my solution. I substitute in to make sure that it is true. Negative 40 divided by negative 5 equals 8, and that is true. So we go ahead and make sure that we box our variable, draw our balance line. We determine what the operation is that is occurring, use the inverse to get our solution. From there, I go ahead and substitute in my value so that I can double check that my solution works.